I'm getting fired up. Yeah! I'm building a campfire simulation using an Arduino and some LEDs on Ron's Trains and Things right now. Hi, I'm Ron of Ron's Trains and Things, and if you'd like to see more model railroad tips, tools, and techniques, then be sure and subscribe below and click that little bell icon so you can catch future videos. Most of us who build model railroad layouts are trying to achieve some level of realism, the sense that you could just walk into a scene on the layout. One of the things that really helps to achieve that sense of realism and life on a layout is including animations, mechanical things that move or that give the appearance of movement and life within the scenes on your layout. One of the sources to be able to help bring those animations to life that has become very popular in the last few years is Arduino. Arduino is open source hardware that has much free open source software or sketches available to be able to help you accomplish lighting effects as well as many other kinds of animations on your layout. Well, today I'm going to be using an Arduino to build an animation project for my layout. Specifically, I'm working on a camp scene and I want to build a campfire that actually glows and looks like it's burning. And I'm going to show you exactly how I did that. Not only wiring the lights, but building the scene and also programming the Arduino in order to make that animation come to life. Now, I am no electronics expert, nor am I really an expert on Arduino, which means that if I, as a total amateur at electronics and Arduino, can accomplish this project, you can too. And I'm going to show you all the resources you need to do that. There are also some great resources available right here on YouTube that can help you learn more about Arduino and how to both build sketches and also download and modify sketches to be able to do all kinds of animation projects for your layout. And I'm going to tell you about a couple of those sources of information in the closing of this video, so you'll want to watch all the way to the end. So let's head on over to the workbench and I'll show you how I did it. I wanted to start just by showing you the effect in this test setup on a breadboard. As you can see, I'm doing this effect with an Arduino Nano. You could do the same effect with any Arduino with an Arduino Uno, but the Nanos are smaller, so they're easier to tuck away under your layout, and they're also less expensive. It's also using 3 LEDs, 2 yellow and 1 red. And I think you can see them there. They're lit, and I know the lighting in here is making the effect kind of wash out, but I'll show it to you so you can see it a little better in a few moments. So we're also just using a few resistors, a resistor for each of the bulbs, and some jumpers here. And I'll show you exactly how I built this and every part that I used and how I figured out exactly what I needed in a little bit. But it has this kind of quivering, glowing effect of each of the bulbs, and they each do so independently and very randomly. Of course, looking at this, it just looks like 3 bulbs quivering, but you have to have something to diffuse the light. And what I've done is I've just taken some wax paper and I have folded it several times so that it is several sheets thick. And I can put that over the bulbs. That diffuses the light a little bit and also reflects it down onto the surface below, which really gives you that flickering flame effect. This creates a very nice firelight effect. And I think it's going to make a perfect campfire for the campfire scene that I'm planning on my layout. The supplies that we need for this project begin with an Arduino. Now, again, you can use any size Arduino that you want. You can use an Arduino Uno. You can even use a Mega if you're planning on doing maybe more than one effect from the same board. But for my project, I used an Arduino Nano. You'll need some LEDs, specifically 2 yellow and 1 red LED for this project. The next item that you're going to need is some resistors. And again, we'll talk about how to make sure you have the right resistor a little bit later. Some things that aren't absolutely essential, but will be very handy as you're setting up your project, are a breadboard like this one, and also some jumper wires. You're going to need some kind of wire to connect this. And if you're setting it up on the breadboard to test it, these jumpers are pretty handy. You can get a large number of them like I have here in this package fairly inexpensively, and so those are very handy. And then, of course, you'll need the materials that you need to build the campfire itself in the scene. But today we're going to focus on the electronics and the animation effect for the campfire. So we'll focus on these materials for right now. So I want you to see the LEDs that I am working with. I am using 3mm LEDs. Which are a fairly small LED, and it makes about the right amount of light, I think, for my in-scale application. You can use any size LED for this project. The important thing is to make sure you have the specs on those particular LEDs. In other words, you need to know what voltage and amperage those LEDs run at, what their maximums are, because that will be crucial to choosing the right resistors, and you have to use resistors with any LEDs to keep from burning them out when you hook them up to the Arduino. Now, if you're not familiar with LEDs, you'll notice that the diodes or the wires on LEDs, one is always or typically a little longer than the other. Pay attention to that because polarity is crucial with an LED. You have to have your electricity flowing the right way, and the longer of the two diodes on an LED is the positive side. So pay attention to that and make sure that you, when you're hooking up your LEDs to your Arduinos, your longer pin there hooks to the actual output pin on your Arduino, and the shorter pin will hook to the ground. I always put the resistor on the positive side whenever I hook up an LED. This diagram shows how the circuit for these three LEDs is connected together, and also how it connects to the Arduino. Let me kind of walk you through how this works, especially for those of you who are not maybe particularly familiar with electronics and electronic circuits. Let's start with the Arduino itself. Notice along the top of the Arduino that set of sockets that are numbered from right to left, 0 through 13. And notice under the middle of those numbers, the word digital. These LEDs, this circuit is going to connect to the digital pins on your LED, not to be confused with the analog pins. Above the Arduino here, we see a representation of a breadboard. Now, if you're not familiar with how breadboards are set up, first I want you to notice that there are two horizontal lines of sockets that are kind of separated from the rest of the breadboard at the very bottom. These are typically used to connect your positive and negative sides of your circuit, and they are connected together, the sockets are connected together horizontally all across the length of those horizontal lines. On a breadboard, typically these are marked positive and negative. There's a space then with no sockets, and then you see a set of 5 horizontal lines of sockets, and then a gray line, and then 5 more horizontal rows of sockets. These two sets of 5 rows of sockets are your working area on your breadboard. Now, note here that these sockets are connected to one another not horizontally, but vertically or across the breadboard. Also note that that gray line in the middle denotes where there is a channel down the middle of the breadboard, and the work areas below that channel are not connected to the work areas above that channel. So you can't set up circuits across that channel unless you use a jumper to connect them together. That's why all of the work on this particular diagram is below that gray line or on one side of the channel. Now that we understand that, let's work our way through the circuit. We'll begin on the Arduino at the far left side. Notice the gray wire that is connected into the socket that's marked GND. That's the ground pin on the Arduino, and this is the negative side of our circuit. Note that that jumper is connected from the ground on the Arduino to that upper of those lower 2 lines, horizontal lines of sockets. That means that all of that horizontal line of sockets is connected to the ground on the Arduino. As we move to the right, you'll notice that there are 3 gray lines or 3 jumpers that connect that negative horizontal line that's connected to the ground into the work area. And if we work our way straight vertically up, you'll notice that those gray wires are connected through the work area to the negative side of each of the 3 LEDs, or the shorter or straight diode. Now, if we look to the right of each LED, the longer or bent diode is connected into the breadboard vertically right above one end of a resistor. That resistor goes horizontally to the right and is connected back into the breadboard, vertically in line, each one of them with a red wire or a red jumper. And each of those 3 red jumpers are connected into an individual pin on the Arduino, or in this case, moving from left to right, pins number 11, 10, and 9. Whenever we download a program or a sketch onto our Arduino, it will tell each of those pins how to act or what to do, and thus it will tell each of our LEDs what they should do. In order to figure out what size of resistor you need for your LEDs, we need to do a little bit of math, and we need to understand one basic principle of electrical theory, and that's the principle known as Ohm's law, which is what you see in a way represented in this formula right in front of you. Ohm's law, if we boil it down to its basics, says that it takes 1 volt to push 1 amp of electricity through 1 ohm of resistance. And so, based on that theory, we're going to get this formula right here. Notice the R, which represents resistance, and resistance is measured in units known as ohms, which are represented by the capital Greek letter omega, as you see in the brackets there. The resistance is what we're trying to figure out, because the resistance is the number that is denoted on a resistor. So the number we're trying to figure out is the resistance or the number of ohms of that particular resistor. Notice that resistance equals this little equation on the right, Vs minus V1, Vs being the voltage of the supply or the voltage that's coming out of the Arduino, and we're subtracting VL, which is the voltage of our LED. And then that quantity is divided by AL, which is the amperage, the max amperage of our LED. And that's going to tell us the resistance that we need, or the size resistor that we need. Now, the Arduino pins put out a voltage of 5 volts. So we can fill in that first letter, that VS, with the number 5. And then we have to look at the specifications of our particular LEDs to know how much voltage they can handle. In my case, the 3mm LEDs that I'm using have a range of voltage that they can handle, but right in the middle of that range is 2 volts. And so I'm using that as my number here, because that's well within the range, both high and low. So the top number I have is 5 minus 2, which of course is 3. So our resistance equals 3 divided by the amperage that our LED can handle. In my case, my LEDs call for a max amperage of 20 milliamps. Now a milliamp is a thousandth of an amp, so 1 milliamp would be represented in decimals as 0.001. 20 milliamps would be represented by 0.020 or 0.02. We're going to divide this, so if you remember from your long division in elementary school, we have to caret our decimal to the right 2 places, both below and above the line, which gives us 300 divided by 2, or 150. So the resistance that we need, or size of resistor that I need in my case, is 150 ohms. In order to build the sketch and download the sketch or the particular program that's going to make this animation work onto your Arduino, you're first going to need to download the Arduino software, or IDE. You can download that from the Arduino website, which you see here, and I'll post a link to that website in the description down below. I searched online to find a sketch to do this particular animation with for my Campfire, And I found several that were available as open source software, completely free. Some were more complex and some were a lot simpler. And the one I ended up using was one of the simpler ones, which I think just made a terrific effect. And the one I found was at this website right here, Instructables.com. And I will post a link to this exact page in the description down below so you can find it. As we scroll down the page, we see some photographs of the how the animation is set up with the Arduino. There's even a video down below. This diagram looks familiar because we looked at it a little bit earlier. Here's a video that shows how the animation looks when it's complete. And then right here is the code for this particular animation. And if you'll notice, the actual code is right here, and it literally is only about 10 lines long. Very, very simple code. It's also easy to customize, which I did. So when you get to this page and you're ready to load the sketch onto your Arduino, you're going to come down here, and starting here with LED light effect, you're going to just copy this all the way down to and including this curly bracket at the bottom, and just copy the entire thing. And then we're going to go over and paste it into our IDE. Now, when you open your Arduino software or IDE, you're going to want to open a new sketch. And when you open it, it'll come up as a whole new file or a whole new window. And you can close down all the other Arduino windows, and you'll have just this one. And it comes up with this available in here. But we're going to just delete all of that out just by highlighting it and hitting delete. And then we're going to come in and right-click and paste the software that we downloaded, the sketch that we downloaded or copied from Instructables.com. And here you see the sketch in here ready to go. Now, what you need to realize about this software is that these first 3 lines right here, they initialize the 3 pins that your 3 LEDs are connected to on the positive side of the circuit, pins 9, 10, and 11. These 3 lines here set them up as output pins, so that the electricity is going to be flowing out through them to our LEDs. And then these lines down here actually set up the flicker of the LEDs that make the fire simulation. And what you're going to see here is that these first 3 lines set a random brightness. The brightness is set by this data right here, which in each case is a random number less than 120 plus 135. Now, when I set this up and tested it, I discovered that my red light was overpowering the yellow lights. And so I wanted to lower the brightness of my red light. And so literally what I did was I made sure that my red light was connected to LED pin 2, which if you go up here to the top, you see that's actually pin 9 in my case on my Arduino. And I just played with these numbers on that pin a little bit. I lowered them down a little bit. And what I think I actually ended up with was a setting of 120 plus 80, which lowered the brightness, the total brightness. It still randomly flickers, but the brightest that it gets is not quite as bright as it was before. And that helped the red light not overpower the light from the yellow LEDs. And then, of course, the last line down here shows the delay, or in other words, how much time passes between the times that each one of these lights changes intensity or brightness, and that's a random number less than 100, and that's what causes the kind of seemingly random flicker that we get in our particular animation here. Now, when you have this set up the way that you want it, then you need to, of course, plug in your Arduino to a port that's connected here. You can use this check mark here to verify. In other words, it'll do a test run of this sketch and make sure that all the lines communicate with one another. And then when you've done that, this arrow right here, you'll see it says over here to the right, upload. When you click that, it's going to upload this sketch exactly as you have it onto your Arduino and it will immediately start running it. And so that's really all there is to installing the sketch or the software onto your Arduino for this particular animation. And once you have wired up your LEDs and your resistors and you have uploaded this sketch, really you have the basics of this model campfire all in place and complete, and it's going to start running. It's going to start working. Once I had my campfire simulation functioning as far as the electronics were concerned, I decided it would be fun to build a simple mock-up of this scene, somewhat similar to what it would look like on the layout. This is always a good idea to make sure that things come together the way you expect they will before you put them on the layout anyway. So I got a scrap of 10,000th styrene from my scrap box. It's about 3 inches square. I began by choosing some tiny pebbles that I made the campfire ring with. These came right out of my yard. I use dirt, real dirt for ground cover for my yard, and I sifted out. And this came from a can of items that I held onto that I had sifted out of that dirt. I put them in a circle about the size that I thought that I wanted and glued them to the piece of styrene with CA. I then came and painted the entire piece of styrene with some tan craft paint. Now, I wasn't overly concerned about getting a perfect coat on this. There's a lot of brush strokes and unevenness. That's all fine. I just wanted to get some color on here. It's mostly going to cover up with ground cover anyway. Once I had the styrene painted, I went and drilled holes for the diodes of my 3 LEDs. I tried to drill them closely enough together to get the LEDs really tight together to make a small campfire, as small as I could. But I had to leave enough space so that especially the 3 positive diodes didn't touch each other because then they would short out, wouldn't work properly. Once I had those in place, I came in and made my diffusion panel, again, with several layers of wax paper that I cut into a circle and then cut a little line in towards the center from the outside so I could twist it into a cone. I then used white glue to glue this cone in place and to kind of push and mesh it around the LEDs. Again, the idea here is just to diffuse the light so you don't see the LEDs themselves, but rather just the diffused light from the LEDs. And it kind of blends the light of the red and yellow lights together. With that done, I got some very small twigs, again, just out of the yard, and began to break them into the lengths that I would need in order to be able to stack them and cover up this diffuser and the LEDs. I wanted to glue them closely enough together that you didn't see the white or opaque wax paper underneath. And you'll see when we finish that even though when I had completed putting all of my twigs on, you can't see anything inside of the campfire, when you turn the simulation on, the glow of the yellow and red bulbs really shines through. It makes an ideal effect. I decided to go on and finish up this little scene by adding a little bit of scenery to it. I sprinkled on some of that real dirt that I talked about a few moments ago, added a few rocks around, a little bit of ground foam, some burnt grass color and yellow grass color, just to add a little bit of vegetation. Used some grass tufts from Noke that I simply glued into place. A couple pieces of talus for some larger rocks in a corner. A couple of sticks for some fallen logs or brush that's laying around. And I had one little scrap off of a tree that I had built earlier, and I put it in the corner as well. And finished off the scene with a figure of a man and his dog, and hidden back among the rocks and behind some of that tall grass, a small fawn of a deer. And so with this, I made a fairly nice little scene for something that I literally threw together in about 45 minutes. But it gives us a sense of what this fire is going to look like when it's on the layout. And here are some shots of the firelight glowing within the campfire. Now, obviously, for in scale, this fire is entirely too big. Again, this is one of the reasons why it's good to mock up a scene like this before you put it on your layout. But the effect is very, very nice, and the way it fits into the scene as far as the light of the campfire effect with the various scenery, I think looks very, very nice. I'm excited about modifying this and then getting it onto my layout as I build my own camp scene in Beggar's Valley on my own layout. I am very pleased at how this mock-up of this scene came together, and I absolutely love the effect of the campfire animation created by the Arduinos and the LEDs. This project was really easy to put together. It only took me a couple of hours to do the Arduino part, get the LEDs working, and as I told you, about 45 minutes to construct the little mini scene. Now, obviously, again, I learned a lot about things that I want to do a little bit differently in this scene when I incorporated it into my layout, but that's why mock-ups are so helpful and so important in the first place. So if you've not yet tried any Arduino projects, I want to encourage you to give them a shot. The Arduinos are inexpensive to acquire, especially if you get some of the better clones out there, and they're a lot of fun to play with, and there's very little pressure because there are so many great resources. Now, I told you I was going to share with you one or two here at the end of this video. One of those is Tom Kvichak at Tom's Trains and Things. Over on Tom's channel, he's been doing a series of videos called Arduino Made Easier. And he's been talking about Arduino projects that you can do. He's been talking about how you can program Arduinos and how you can modify sketches to do all kinds of different projects. So if you want to understand more about Arduino from the basics and how to build things for yourself using Arduino, I want to encourage you to head over to Tom's channel and check out that playlist, Arduino Made Easier. I'm going to include a link to that playlist in an end card at the end of this video, so you'll want to go check that out. Well, if you enjoyed this video, here's a link to some more videos that I know you'll enjoy as well. Also, before you leave, I hope you'll check out the description down below. There you're going to find a link to my Patreon page, and there you'll see all of the items that I used to build this Arduino project, as well as a number of other items that are excellent for model railroading, for video making, and all kinds of other projects. And even if you do your regular Amazon shopping through that link, you'll be getting the same great prices and service that you always get from Amazon, and helping to support this channel at the same time, so I hope you'll check that out. Also, check out the link to my Patreon page, as well as ways that you can connect with me on social media. Those and all of the links that I mentioned in the video to help you build that Arduino project, it's all in the description down below, so be sure and take a look. I hope you'll join me again next Tuesday as I'll be bringing you another great model railroad segment, and I look forward to seeing you then. Lizzie?